For these problems, we're going to use the sine function to find the value of x. So if you recall, the sine of an angle theta is the opposite over the hypotenuse. Okay, so if we look up here, we know we have three pieces of information. We have two sides and an angle, and if we think about it, if we think about this angle being theta, okay, this 62-degree angle being theta, we have the opposite side and the hypotenuse, so we can just take this right here and plug everything in that we know. So we know that the sine of 62 degrees equals opposite, which is x, over hypotenuse, which is 12. And then solving for x is really easy. So all we're going to do is we say, okay, well, we don't like this 12 in the denominator, so we multiply this side by 12. Check your later denominator. And then whatever we do to one side, we have to do to the other, which means we have to multiply this side by 12. So then we end up with 12 times the sine of 62 degrees equals x. So then you just literally, it's a calculator problem. You just say, okay, 12 times the sine of 62. Now, just make sure your calculator is in degrees and not radians, because you don't want to make that mistake. You'll get the wrong answer. And when we do that, we end up with, if I want you to round to the nearest tenth, we end up with 10.6. So then always write it, I always tell my students, put the x on the left, so x equals 10.6. Perfect. Okay, now, sometimes students don't like to do this, they like to have numbers, so another suggestion that I always have that you can do is if we kind of rewrite it over here and we say the sine of 62 equals x over 12, you can always figure out what that is numerically. You just literally type in sine 62 into your calculator, okay? Again, make sure you're in degrees, and what you'll end up with is 0.8829 equals x over 12, then multiply both sides by 12. And then you'll end up with the same answer. You'll end up with x equals 10.6 if you're rounding to the nearest tenth. So sometimes students like to do it this way because they say, oh, I want to see this as a number. I don't like the fact that I'm multiplying 12 by something that's not a number. So it's perfectly fine if you figure out what the sine of 62 is first and then you multiply it by 12. Either way will work. All right, so I'm just going to delete this, mainly because I don't want to run out of room for the problem that I'm going to do on the other side. All right. So that was easy. So that was an example of where the thing we were solving for was in the numerator. Okay? And so as you can tell, there's three spots. Okay? There's the numerator, there's the denominator, and there's the angle. And basically these three problems we're going to solve for x in each of those three places. Okay? So let's do the next one over here. So again, we're using sine because I told you. So if we look at this angle, it's 50 degrees. So I'm just going to write theta equals 50 because when I start making lines, we might not see that. Okay, so I go here, opposite. Perfect. So I know that the sine of 50 degrees equals 3 root 5 over x. Okay? Now, I'm solving for x, and x is in the denominator. So the best way to put in the numerator is just to multiply both sides by x. Right? Check your later denominator, and I have now moved x over here. So what I'm looking at is x sine 50, so x times the sine of 50 equals 3 root 5. And if I want to isolate x, remember these two are attached by multiplication. Okay, so see that? I know they're kind of close, but x times the sine of 50 degrees. So how do you undo multiplication? With division. So if I divide this side by the sine of 50, check your later sine 50 over here, divide this side. Perfect. And then I end up with x equals 3 root 5 divided by the sine of 50 degrees. Okay? And then again, you just plug that into your calculator. That's an S for sine of 50 degrees. So you just do 3 root 5 divided by sine of 50, and that will come out to be, rounded to the nearest tenth, 8.8. Okay? Now, that was the long way to do it, and you might have realized something. So let me write it over here in, we'll do gray. So when I had the original setup, I had the sine of 50 equals 3 root 5 over x. Now, if you recall that, look at what's going on here. All that happened, and I'll do it in red so we can see it better, was that the sine of 50 and x switched positions. Look at that. That's all that happened, okay? Whenever x is in the denominator, okay, originally, it can just flip-flop with something. Now, again, this is very specific, okay, to this case, or cosine or tangent, either case like that. But they can just flip-flop positions. And the reason for that is what you really did was, you can see, you multiplied both sides by x, okay? That caused the denominator to go away, the x to be on the other side, and then you divided both sides by sine 50, which basically it caused the x to go over here and the sine 50 to go over there, okay? You can just remember that, okay? When x is in the denominator and I'm using, sine, cosine, or tangent, I can just flip-flop it with something over here. Now, if there was like a +5 or something else going on, you can't do that. So it's just in this specific case where, think about it as we only have 3 spots. We have, let me come over here. We only have 3 spots. So if you think about it, we have sine, theta, and then we have, let's just say, x over y. So we have 3 spots, and you can see we have here, here, and here. So as long as it's in this form where there's 3 spots, you can do the flip-flop. In this case, it would be the sine and the y, okay? Or you can do it the long way, the way I did it, okay, to make short. I always told my students I have no problem if they do the flip-flop, but what if I kind of throw something in and make it a little more difficult, and then they do the flip-flop, and then mathematically that doesn't work. So it might be safer to do it the long way, but if you can remember, then you can do the flip-flop, which is shorter. Okay, so let's try one more problem down here. All right. Let's get that over here. Okay, so here's the final example. Remember I told you how I was going to be putting x in 3 different spots? So again, we're using the sine. So in this case, it's the sine of x, and there's our opposite side, and this is obviously our hypotenuse. So it's going to be the sine of x equals opposite over hypotenuse, so 2.1 over 5.3. Okay, now how do we do this? Well, we're solving for the angle now. So whenever you're solving for an angle, okay, when solving for the angle, you're going to use the inverse. Okay, so the inverse sine, okay? So basically, think of sine as an operation, so the sine of x, okay? We're doing something to x, we're taking the sine of it, all right? So now you have to undo that. So what you're going to do is you're going to take the inverse sine, okay? So you're going to take the inverse sine, because remember the inverse undoes, okay? So the inverse sine of sine x, and then whatever you do to one side, you have to do to the other. So you're taking the inverse sine of 2.1 over 5.3. Now, I noticed when I was teaching, a lot of students would say multiply it by the inverse sine. You're not multiplying it by the inverse sine. You are taking the inverse sine, okay? So the inverse sine of the sine of x is just x, okay? And then the inverse sine of 2.1 over 5.3, that's just in your calculator. You just do it in your calculator. And what you'll end up with, we're rounding to the nearest tenth, is 23.3 degrees. Perfect. Okay, so now what I want you to think about again is just to kind of show you. I showed you that the inverse sine of the sine of x is x. And some of you might have been like, whoa, whoa, whoa. Well, think about it. We performed an operation on x, we took the sine of it, and then we took the inverse of it, which means we're going back to the original. So this is what I want you to think about. Pick a value that you know. So the sine of 30 degrees. Okay, we all know that the sine of 30 degrees is an easy one, is 1/2. But watch this. If you were to type the sine of 30 degrees into your calculator, okay, you'd end up with, let me put this over here, so sine of 30 degrees is 1/2. You'd end up with 1/2, okay? Well then if you took that 1/2 and you took the inverse sine of 1/2, okay, you're going to end up with 30 degrees, okay? So that's essentially what we did here was we had the sine of 30, we're going to take the inverse sine of that, and we're going to be back to where we started, okay? So things are a little bit more complicated with that, you'll see later on, but for now, this is what's going to happen. You have the sine of 30, you take the inverse sine of that, you're back at 30, so it's the same thing over here. The inverse sine of sine x is just x, okay? So that's how we go from this step to that step. And then whatever you do to one side, you have to do to the other to make sure that everything stays equal. So you have to take the inverse sine of this ratio, 2.1 over 5.3. So there you go. Those are the 3 places that x could be. So if you can do every single one of these problems, then you're set. You know what I mean? So stay tuned because I'm going to do some for cosine and some for tangent.